Hello everyone, this is Shiva, right? So in the previous example, I already said that right, this model, right, when two strings, if we take two strings and two bodies, and immersed in some fluid, right, then buoyant force will act. So this is that kind of problem, right? So if you see this here, there are two identical non-conducting solid spheres of same mass and charge, right? And they are separated in air from a common point by two massless strings of same length. So this one we take it like this. And the at equilibrium angle between the strings is alpha, right? So I took the liberty of the symmetry, and half angle I took it as alpha by 2 and alpha by 2. Now the spheres are now immersed in liquid of density 800 kilogram per meter cube and dielectric constant 21. If angle remains same after immersion, then, right? Okay. So before immersion, this thing we already know. If we resolve tension into the components and take the equilibrium conditions, then we get this result, right? Since equilibrium angle separation, half separation angle is alpha by 2, tan alpha by 2 we got as f naught by mg, and this is pretty standard result we have already seen in the previous example, right? So now these two are being immersed in some liquid, right? So when we immerse in these things in liquid, buoyant force will act, right? Try to lift the body upwards, right? So I took the buoyant force component upwards. So now taking this one into the account, I have written the equilibrium equations, right? T cos alpha by 2 upwards, fb is also upwards, mg is downwards. So T cos alpha by 2 plus fb is equals to mg, and T sine alpha by 2 is acting in this direction, and coulombic force, right, is acting in this direction. Coulombic force before immersion I took it as f naught, after immersion I took it as f1, because obviously when we when we introduce some medium between the charges, coulombic force of repulsion or attraction, that changes by 1 by k, right? So since the force changes, that I took it as f1, which I equated to T sine alpha by 2. So T cos alpha by 2 is equals to mg, f becomes this side. So these are pretty things, right? Tan alpha by 2 from these two equations I've written, right? And also in the question they mentioned that the angle remains same, right? So that means this equilibrium separation angle, half separation angle is not changing. So alpha by 2 before and after immersion also alpha by 2 stays the same. So tan alpha by 2 and tan alpha by 2. So I'm equating these two components, that is f naught by mg and this expression, excuse me. So f naught by f1 is equals to this we got, right? F naught divided by f1, right? When we introduce some medium, right, that will be, the force will be f naught by k, right? That we've seen, f naught gone. So mass I've written as density into volume. So mass is density of the body into volume of the body, right? And buoyant force, right? Body is completely immersed, so that's why density of the surrounding medium into volume of the body immersed into g, right? So from here k we'll get this one, right? And this is pretty standard one. K is dielectric constant, right? So from the given problem, dielectric constant they're given as 21. So I took 21 here, right? And yeah, so from here I've written this one, and if we compute that we'll get rho b, that is density of the body, as 840 kilogram per meter cube. Everything is in SI, so as it is I substituted. So we got this option, mass density of the spheres is 840 kilogram per meter cube, right? In the first option, force between the spheres remains unchanged. That is not correct, because since the given separation angle is not changing, right, and if we introduce some charges into some medium, or I mean if we introduce a medium into the charges, well, same thing, then force, right, changes, right? If force is not changed, then that means distance would have changed, but distance is not changing because separation angle is not changing. So that means tension and force both should change, right? So first option remains unchanged again, so that's not correct, and second one is correct. And fourth one, also tension is not changed they're given, but tension will change, right? Okay, so this is an example. There is also PYQ by the way, right? Advanced I guess. So yeah, This is this kind of model, right? When they immerse this charge for this setup, they introduced into some the dielectric medium. Then yeah, what is the relation between dielectric constant and density of the body and liquid, right? So yeah, based on this arrangement, I have one more problem. I think it's from NEET, I guess. Yeah, we'll solve that in the next problem. So thank you very much. I'll see you in the next video.